Hello students, welcome to Sarasa classes, and today we will be discussing Bend's rule and few more examples. Okay, so this is in connection to the previous lecture 1 on Bend's rule. As we had learned that Bend's rule predicts that the most electronegative atom should be occupying the axial bond and the less electronegative atom or lone pair should be occupying the equatorial bond. So this is something we have to keep in mind, and let's take out the new examples. Suppose you have been given a molecule of the type AB3L2. That means what? A again is your central atom, B is the substituent, L is the lone pair electrons. So out here we are having 3 substituent atoms and 2 lone pairs. Okay, so that is something we have to keep in mind. So that would mean again we have total electron pair, that is going to be 5. So that is going to be our steric number. And so again the hybridization, we will say it is going to be sp3t. That is the hybridization of the central atom A. So let's take examples of the type AB3L2. Okay. So examples are going to be over here ClF3, okay, ICl3, all right, or XeOF2. So these are our examples. Let's do the total electron count of ClF3. Okay, so total electron count for the ClF3, or let's say what were we saying before, that is total valence electron count. Okay, so for Cl it is what, 7. Fluorine also it is 7 times 3, so that is going to be 28. 28 again is a number more than 8, so by rule we will divide it by 8, and we know 8 will go to 28 3 times, so it is going to be 24 initially. So like I said, the initial quotient that you get is going to be always your bond pair. That is how you find out which is your bond pair. What is the remainder? 4. Number is less than 8. Divide by 2, and so that gets cancelled. 2 again is a quotient. So second time from the remainder, the quotient that you are getting is going to be what? Your lone pair. What is the total electron count? 5 electron pair. What is the hybridization then? We will say sp3d. Since there are lone pairs and bond pairs, Bend's rule you have to apply to predict the correct structure. So let's draw the structures, possible structures, and then we will predict. Okay, what do? We write Cl. Okay, and 2 lone pairs I'm writing initially like this, and these are my axial bonds along the z-axis. So my coordinate system is basically like this. Okay, understand? This is always z, this is always x, and that is always y. Okay, so whenever I'm saying axial bonds, that means it is lying along the z-axis. So I will say fluorine, if I place over here, here, that can be one structure with these are the electrons or lone pairs. What is the other structure that we can have? Suppose I have placed the lone pairs along the axial bonds and the fluorine on the equatorial bonds. So now I have generated two different structures, and now I have to find out which is the correct one. Okay, so according to Bend's rule, lone pairs should always occupy the equatorial bonds. Okay, so which are your equatorial bonds? Again, these are your equatorial bonds, and these are your axial bonds. Lone pair should never occupy the axial bonds. So again, our correct structure will be this one, and the incorrect structure will be that one. Okay. Same thing can be done for ICl3 or XeOF2 also. Okay, so that is something I'm leaving for you to practice. Now, out here, as we said, the hybridization is what? This is our hybridization. Is it a regular structure? No, it is not. Why it is not? Because it is having two lone pairs. So over here, geometry, which is hybridization, and shape will never be equal. Okay. So now, what is the shape of the molecule? If we have to predict, we will say that the shape of the molecule will be represented by the bond pairs only. And if you consider this shape and forget, so if I erase these electrons now, what is the shape that you see? It looks like a letter or alphabet. So what is that alphabet? We will say it is T-shaped. So we will say the shape of the molecule is T-shape. Okay, next, let's do a few more examples in which I will be taking up a molecule of the type A, B2 now, and L3. So again, what we are having? We are having two bond pairs and three lone pairs. So obviously the total electron pair is 5, which means this is your steric number. So your hybridization is what? Again it will be sp3d. So we can see one thing over here. A molecule can be AB5, AB4L1, AB3L2, or it can be AB2L3. All of these, if you say what is the hybridization, you will say sp3d. But when you go for looking for the regular structure, you will say this is only the regular structure, and the rest, which I'm highlighting as green, these are all your irregular structures in which the hybridization and the shape, they are not equal. Okay, so that is what you have to understand clearly. So let me highlight it again properly. So these are your irregular structures. Okay, and for the regular structure, what was the shape? The shape was TBP, that is trigonal bipyramidal. This one we said it is seesaw. Okay, for this one we have predicted in the last example it is T shape. Let's see what is this one. So for this I am taking examples like XeF2, ICl2 minus, or this is called triiodide. Okay, so basically this is your polyhalide. Now let's do the total electron count for XeF2. So total valence electron, X means 8, for fluorine it is 7 times 2, so that will give you 22 electrons in total. 22 is a number that is greater than 8, so we divide by 8, so quotient will be 2. We have 16. If we subtract, we get 6. Number is less than 8. This is our remainder. We divide by 2. That will go 3 times. So again, this is what? Bond pair. That is what? Lone pair. Total electron count, 5 electrons. Hybridization, from that, if steric number is 5, we will say hybridization is sp3d. So again, we have to predict the correct structure. So let's write the central atom like this. Okay. And we have now 3 lone pairs. Okay. So let's check the possible combinations we can have. We can have something like that. Now understand, I could have placed the lone pair here and the fluorine here. So the previous one and this structure, they are all the same. Okay. Idea is, here 2 fluorine are placed in the equatorial bond. 1 lone pair is in the axial, in the equatorial, and the rest 2 are in the axial. Okay. So that is the idea. What can be the other possibility? Place all the lone pairs in the equatorial plane and the fluorine in the axial. And now let's think of Bend's rule. Fluorine is more electronegative than the lone pair. Okay, and so we will say that the lone pairs should be, according to Bend's rule, should be placed in the equatorial plane and not in the axial plane. So structure number, say this is A and this is B. So this will be my correct structure, this will be my incorrect structure. Okay, so that is how we have to deal with this type of examples. That is what we were to discuss in our second lecture. Thanks for listening and have a great day.